Hello, welcome to another episode of Miss Dawson Tries to Teach from Home. So anyway, yesterday you guys watched a video about bloodstain pattern analysis from an expert within the field. Today we're going to talk about one of the topics that was covered in that video, but we haven't looked at in depth yet. So it was kind of just an introduction yesterday. So we've talked about how blood stains look when they're dropped straight down from 90 degrees. Your assignment after that was looking at how the angle of impact can be measured based on just the width and the length and taking the arc sine of that. And today we're going to take it one more step and figure out where the wound was or how tall that person was at the time of the bloodstain pattern. Okay, so this is just adding yet another detail into our crime scene reconstruction. Okay. So when you look at this lab, the very first part of this lab, a lot of it's just background information. I would read it. Okay, so first page, second page, read on your own. Okay, that kind of gives the background to what we're going to be doing. I'm going to take this time and explain some of the math behind it. Okay, so if you keep going to the next page, I'm fairly confident that you'll be able to answer the questions 1 through 6, because a lot of that just comes from the first 2 pages of background information. And then we'll go ahead and go to question number 7. Just can't move it. All right, so on this page, we see that we've got 2 blood stains here. Okay, 2 blood drops. Blood drop number 1 and blood drop number 2. So our very first step, we're actually just going to do the same thing that we did on the previous assignment, that angle is everything assignment. We're going to do the same exact thing. To make our lives a little more easier with this being online now, I went ahead and measured them for us so we have all the same measurements. So once again, I measured the width, and then I measured the length from the tip of the drop to right about where the tail starts. So let's go ahead and we'll just have everyone use these measurements here. So both blood drops measured 1.1 centimeters in width. Blood drop number 1 measured 4.2 centimeters in length, and blood drop number 2 measured 3.9 centimeters in length. Now you're going to then do the same thing where you use the arc cosine, okay, with the width over the length to get the angles for these two, the angle of impact, and then you're going to average them together. Okay, so that would be the rest of the chart. Right? Then I know you know how to do, so I'm not going to waste my time doing that. We'll go to the next part. Now the number 8, okay, it says write your average angle of impact in the appropriate spot on the triangle below. Okay, so what this is kind of getting into the next step of the law of convergence. So here we have our point of origin. Now this would be where the wound is that is causing the blood spatter. So let's say someone received a gunshot wound to the head. Okay, their head would be there, and this would be them standing up. Okay. Oh no, he got shot in the head. Okay, so this is not going to be our angle of impact here. Okay, this is just the 90-degree angle that we have that forms whenever someone is standing. And then this would be the distance it is from that particular victim to where we find the blood spatter at. Your angle of impact is going to go right here. Okay, so when you figure out what this answer is, all you have to do for number 8, even though it looks like a lot, all you have to do is write this answer right here. Okay, and that's all you have to do for number 8. Okay. Now, if we keep going into number 9, number 9 is kind of just more background information. Okay, so from your reading, it's basically just asking what does that circle mean. You'll read about that on page 1 and 2. And then we're going to get into the actual mathematics of this. So all we've done thus far is literally the law of sines. Now we're going to take it one step further to figure out the line of convergence, also sometimes known as the law of we use the law of tangents to find the law of convergence. Okay, so if we think back to our original crime scene, which is the one that we began talking about all the way back here in number 7. Okay, so if we go all the way back to this original crime scene that we talked about in number 7, we are going to go ahead and figure out where that person was or how far up their wound was. So it says write the average angle of impact in the appropriate spot. Okay, similar to what we did in number 8, it's just our triangle's tilted a little bit. So once again, this would be the height of that particular wound. Okay, this would be the floor or the distance. And so that angle of impact, okay, would be right here. So whatever that, struggling here, okay, whatever you got for your answer right here, you're going to write right here, okay? Pretty much the same exact thing you did in number 8. All right, this is just us doing it step by step, okay? So this is your average angle. I'll just write outside the box, it's fine, okay? And then we have to figure out the distance it was from where that victim was standing to where that first blood drop is. So normally you would measure this, and that's what it says there. So it says measure the distance. Bloop, bloop, bloop. Sorry, I keep going off the screen. Okay. Measure the distance or the adjacent side, so the side right next to the angle of impact, in centimeters. For the ease of us doing it online, I measured it for you. It is 4.8 centimeters. And then it says, note, this picture below has a blood drop drawn to scale, but the distance is scaled to 1 centimeter equals 5 feet. All right, so to get this answer, you multiply 4.5 by 5, and you would get your answer in feet. Okay. Now, we've gotten our angle of impact. We are going to multiply 4.5 by 5 to get this distance here. Okay. Now you can go ahead and put it into, and this is what number 11 looks like on the back. I'm just not going to flip the page because it's a lot of flipping back and forth. So all we're going to do is put this into our formula here. So we're going to take the tangent, okay, of this angle, which is our average angle. Okay, so whatever we figured out all the way back from number 7, you're going to put that number in here. Okay, so average angle goes in here, and then we're going to have a ratio, and we have the opposite over the adjacent, okay, is what our law of tangent says. Now the opposite is going to be the height of that wound from the floor. Okay, we are trying to figure that out. So in this mathematical equation, that's our unknown variable. However, we do know the adjacent, okay, because we figured it out down here. So whatever you got for feet, you would put right there. Okay, and then you can use your calculator or any of your online scientific websites. You would just use regular tangent. You don't have to do the inverse tangent. Okay, so just regular tangent of whatever your angle is. Okay, hit the equal sign, and then you're going to multiply it by whatever you got here to get this x. And that x will equal the height of the wound. Okay. So a lot of times students will think it's the height of the person, and that's not necessarily always true. If they got shot in the head, then yeah, it'd be close to the height of the person. However, if they got shot in the abdomen or in the knee, okay, this might be a very short height, okay, because we're doing it from the height of the wound. Okay. Number 11 just kind of takes you through that, and then number 12 is another example where you're going to implement that. Okay. If you have any questions, please let me know. Okay, watch this video a couple times over. Use the measurements that I measured for you to help answer that out. And make sure you read your background information as well. I hope you guys are doing well. Have a good one.